Hello, we're back here. Now you might notice I've kind of just rubbed bits out and created a bit of space here for take two. My class just said, so we don't really know what natural logarithms are, and we didn't really do logs last year. And I went, rubbish, of course we did. Went and checked the syllabus, it comes up in 4.1, so that's next semester's work. That's okay. I'm going to show you this idea a different way. Okay? Hopefully I get through here, because this is like 2 minutes after the last video. Okay, so if I want to differentiate, or was just here, if I want to differentiate e to the x, right? Let's do it this way. Let's do the limit as h approaches 0. Now you should straight away go, hang on, I've seen this a couple of times. So limit as h approaches 0, remember it's f of x plus h minus f of x over h. Okay, but I'm not going to write that. Check previous videos. I'm going to put it in this situation now. Wouldn't it be e to the x plus h minus e to the x over h? Because this is f of x plus h, this is f of x. Okay? So that we should be okay with. I'm hoping we're good here. Limit as h approaches. Right. Now what I'm going to do, I'm going to do a little bit of rearrangement with this. I'm going to take a common factor of e to the x out front of e to the h minus 1. Okay, just check that you agree with that. Because I'm adding them here, I can split them up and they become multiply, because when I multiply my indices, my exponentials, I add the powers. So that's okay. Now what I want to do is I want to work with this guy here. Okay? Now initially when you look at that, and if you're a little step ahead, you might go, but hang on, this is going to cancel out. This is going to disappear. Well, think about this. If you put h equals 0, or approaches 0, into there, e raised to a power that is closer and closer to 0 is going to become closer and closer to 1. Because remember, if I did e to the 0, that's equal to 1, isn't it? Anything raised to the power of 0 is equal to 1. So e to a power very, 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 very close to 1 is going to be very, 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 very close to 1, isn't it? Okay? So wouldn't that then mean that this top line is effectively equaling 0? Well, that's going to cause an issue, isn't it? But we don't go down that route, it's correct. We actually bring in this as well. Because if this is getting very, 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 very close to 0, it's not actually 0, but getting closer and closer and closer to 0, then if I divide it by something that is also getting very, 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 very close to 0, I'm dividing a very, very small number by another very, very small number. Let me do that again. I can see a few blank faces and a few, oh yeah. This part here, this bit, is doing this because h is getting smaller and smaller and smaller. So that is getting closer and closer to 1. It's closer and closer to 1, but never equal to 1. So this will be a very, very, very small number because it's slightly greater than 1 minus 1. If you're unsure about that, put something like this into your calculator. You'll get, it'll be 1.0000, something like that. Right? So if you have that there, then slightly more than 1 minus 1 is a really small number, isn't it? And then if I divide that by a really, really small number, isn't that whole thing in the red going to just approach 1? You see what I mean? I've got more, yeah, and a few still, I don't know, just a little bit more than 1. Just a little bit more than 1. Minus 1 makes a very small number. Divided by a very small number is going to be very close to 1. And remember, all of this is as h approaches 0, so we're getting infinitesimally close to 0. Okay? So as it approaches 0, this top line becomes very, very small, a bit in the bracket, divided by a very, very small number, would mean then that that whole thing is effectively tending towards 1. And that would mean then the limit as h approaches 0 of this whole thing is just equal to e to the x. See, I told you I wasn't lying, even though I did it in a different way over there before. Hopefully this style works better for you. There's a lot in here. There's a huge amount in here. So if it doesn't make sense, watch it again, watch it again. Check up Eddie Wu if you need. Nah, don't check up him. He's no good. No, I'm joking, Eddie. I'm joking. But this is one way of doing it. Really, really good to show that the derivative of e to the x is just equal to e to the x. Thanks, guys. Catch you later.